Hey Barry, where are you? Fancy flying over here to give us some more tips on web performance?
Performance, you say? No need to wait, Jecelyn. I'm here. Let's dive right into recording traces and exploring the performance panel. First things first, Chrome extensions can sometimes mess with performance recordings. It's best to use incognito mode for a clean analysis, or even create a dedicated Chrome profile just for this kind of work.
Right, and it's also important to remember that developer laptops are usually pretty powerful. So, adjusting the settings to simulate a slower environment is key to getting realistic results.
Absolutely. This live metrics view can be used to spot potential performance issues. For example, we already know this image is our LCP image, and it's looking a bit sluggish. Let's record a fresh trace with this record button and see what's causing the slowdown.
Wow, there's a ton of information on this screen. Where should I even start?
In general, there are a number of sections on this screen. The Insight sidebar on the left and the timeline at the top are usually the best place to start your investigation, to get an overview of the trace and the key issues. Then we can focus on the detailed tracks to get more information. Since we're focused on LCP, let's expand those key insights. That'll highlight the most relevant parts of the main track and the network track. Now let's zoom in on the timeline and select a portion of the trace to focus on. Here we're looking at the first few seconds of the page load. In this example, we can see that LCP is happening way after the initial loading timings, DOM content loaded or DCL, first paint or FP, and first contentful paint or FCP, and even after the full load time. We love our acronyms in web performance, by the way. Let's look at the LCP image. Whoa, look at that download time. Hovering over it gives you the detailed timing info, and it's taking a long time to download. In the summary, we can see it's because of the file size. Optimizing the image size and format would definitely help with that in this case. Also, notice how the initial priority was low before it got bumped up to high.
I'm guessing this image is probably lazy loaded, which is not ideal for LCP images.
You're absolutely right. That's why, even though the image was initiated by the HTML, it had to wait for the purple CSS to load before it even started downloading. That's because the CSS is needed to know the whole page layout, to know whether the image is in the viewport or can be lazy loaded later. Let's fix all these issues. We'll optimize the image, remove the loading equals lazy attribute to stop delaying it, and in fact even add fetch priority was high to do the opposite and ensure it starts downloading as early as possible. We record a new trace again, and there you go. The image loads much earlier now. It's also faster to download because it's smaller, and the LCP score has improved dramatically.
I'm impressed, Barry. I love how we can see the network resources right alongside the other performance data. It makes everything so much clearer.
Absolutely. And we've only scratched the surface. Being able to see these network requests lined up with the flame chart in the main thread is another incredibly powerful tool for understanding performance bottlenecks. See how the font size jumps around? That's not a good user experience. CLS is the metric we use to track that kind of visual instability. The score might look decent, but I bet we can still improve it. Let's take a look at the trace. In this case, I'll just move my cursor along the timeline to see the screenshots and pinpoint when the layout shift is happening. You'll also see these in the layout shifts track.
Found it! Let's zoom in. I love that we can zoom multiple times and use the WASD keys to adjust the select region. Oh, that's the font file loading.
Interesting. It seems like there's some spikes in JavaScript activity.
The main track is probably the best place to start digging into that. Oh look, there is a timer fired event right here. Let's click on that and open the event log tab to see what's going on.
Aha! There's a render fonts function. Let's click on that to open the source file. I see. It looks like we're dynamically injecting a style tag to load the fonts and then delaying the whole process with a set timeout.
Maybe we could just remove this code entirely and load the font face upfront with inline styles?
I bet we can. Let's do it.
Wait a minute. I know Jeremy is working on this part of the code right now. We should probably let him know about these potential issues instead of just making changes ourselves. Let me take a screenshot.
Wait, stop. I know a much cooler trick than a screenshot. We can annotate the trace.
And no, what now?
Watch this. We can right-click and label the entry. You can even label the network of it too. And not only that, you can link these entries together to tell the whole story. Then you can navigate and manage all your annotations in the sidebar.
Whoa, this is so cool. Let me take a screenshot now to share it with Jeremy.
That's still a no, Jecelyn. You're so old school. We can export the trace and share it instead. Jeremy can load the trace later with all the clues we've left for him.
Wow, this is awesome on top of awesome. This is going to make collaboration so much easier.
Let's see what they're telling me here now by looking at this trace they sent me. Oh, that's not right. Nice spot. Yeah, that's definitely some test code I left in there that shouldn't be there. Whoops. You know what? Annotations are so handy for collaboration.
Oof, that's a lot. I hope you found it helpful and that all this info helps you track down and squash those performance bugs faster.
I'm sure it will. And good luck debugging, everyone.
See you for the next step 2 tips.
Ciao!